Any questions so far? So I hope by now we have fairly good overview of which tools are out there and what they can do and what they cannot do for us. Okay? Now let's look into some other potentially interesting solutions which are available out there. And one solution is called crowdsourced testing. And the idea here is that we have some developers and testers that basically say we're going to hire other people to test our application. We don't know these people, but we're going to hire many of these people, right? And they somehow are going to test this application and they're going to give us bug reports. Okay? And in fact, this has been pretty interesting idea because I was able to find at least several different startups and companies around this idea. One is called Pay for Bugs. Basically, you describe the project, and then I didn't go through this whole process, so I don't know how much you paid. But the idea here is that you describe the project, and then you get the code, and then you get the code that tells you these are resources that we can allocate, and this is the format. It's good. Excuse me. Excuse me. So, another solution is called Test Army. Idea is fairly similar to the first one. These guys claim they have over 2,000 testers. But what I would like you to pay attention to is that you see the model is slightly different. They say we're going to create scenarios for the application, okay? And then we choose a number of devices for testing, okay? And then they can assign this to some testers, and then they're going to verify those reports, bug reports, and they're going to give you the results, okay? I'd like you to pay attention to this point because it will be clear why and how we designed one of the solutions, hopefully to do this whole thing adequately. There are also some solutions for remote automated and manual execution of the application on your devices. Basically, what these companies do, they build device farms. What device farms are, they connect lots of these phones and tablets to servers, right? And then they also have servers that run lots of different emulators. And what you do, you pay for certain devices and for time for using these devices, and you can do testing by relying on the APIs and frameworks to essentially enable it on different devices. Also, there are quite a few solutions to enable and support usability testing. Like this is an example how usability testing is done in this context. So you have a potential user who is using the application. You have the scribe who is taking the notes here. So they observe how the user uses applications, emotions that the user experiences, as well as maybe some problems. And then there is a review session where they basically analyze user experiences and they try to suggest improvements for design of this application. And of course, there are lots of different commercial solutions. This one is called Mr. Tappy. And the idea behind Mr. Teddy is, we have the video here. No, I don't. But the idea here is basically you record how you use this application, and then you later can analyze this footage to make improvements. Of course, we have lots of different testing automation frameworks. Google recently actually open sourced their framework. So basically, what you can find here, you can find some examples of using UI Automator and hierarchy viewer. And basically, using these frameworks is as easy as calling some APIs, right? So in this particular case, we can easily trigger inputs to certain GUI components of the screen by means of calling certain APIs. So this is actually one interesting startup which comes from Georgia Tech, and the idea behind this tool is, as a tester, you can interact with the application just naturally, and the idea here is we have a tool which is going to generate the high-level test script for this particular scenario that you're doing on the phone. Okay? So in this case, you interact with this application, and on the right-hand side, you see that these are results of the tool. So these are test scripts that we generated for that execution. Okay? You can barely see here, but basically this is a source code, and you can easily modify it. You can update it. But this is fairly convenient, right? Because you don't need to write it by hand, right? You just need to execute the application and you get this test script. Also, there is a solution called Xamarin. The idea here is that basically you test your applications in the cloud. So they run the test farm on devices somehow, and you just buy time on certain devices to test the applications. And obviously Amazon has very similar service, and of course Google has very similar service, so there is a lot of competition in this area. And there are some also open source available solutions from Google. This is an approach for automatically detecting and reporting crashes in Android application. And of course Google has their own crowdsourcing solution, which is right now in beta version. There are also pretty cool tools like Visor. What this tool allows you to do, it allows you essentially to connect your Android and basically interact with your phone through the window on your laptop. So like in this case, it's fairly easy to connect your device, and then you don't have to actually do the actions on the phone. You can just test them from your laptop. Fairly easy. And there is another really cool solution which is called Smartphone Test Farm, STF. It's an open source solution which allows also remote execution of applications in emulators through the browser. So the idea here is you can run your server with different emulators somewhere, but you can interact with that application and emulator through your browser. And actually now that we've been heavily tapping into this open source solution, I'll talk about some of the extension that we implemented in this framework to enable collection of low-level events through the browser to enable crowdsourced testing. And again, in this case, that's how we interact with the phone. So it runs somewhere, but you work with this phone via the browser. So it's pretty convenient and cool. So as you can imagine, you can do lots of things with these kind of solutions, right? You can hire people to test the application who don't even have phones, right? They can be just interacting with that application in the browser. So up to this point, I covered different tools, which include multi-pass testing, various testing automation frameworks, record and replay tools like Barista, and some of the existing solutions for crowdsourced testing and cloud-based testing. And of course, we already knew about some of these limitations of some of these tools. Yes, Monkey is good for helping us with unexpected scenarios, but reproducibility and expressiveness will be prominent. Testing automation frameworks are great because they're easy to reproduce. Potentially, you can automate the execution of different devices. However, the problem is that you will actually need to maintain and update these test circuits, and of course, there's a learning curve. Recorded regularly, potentially, you can automate on different devices, but at least there are no solutions available out there for this task. It's similar somewhat to manual testing because you have to record real execution scenarios, but again, you'll be dealing with a test script maintenance problem. These crowdsource-based solutions offer lots of benefits because you can potentially test the application with a large set of devices. Many of them allow remote data collection, and they support automation frameworks as well. So now let me show you a couple of tools which are extremely useful in testing model applications. This tool is called Hierarchy Viewer. This is actually one of the earlier tools we used in our research to build systematic exploration tools. Essentially, what Hierarchy Viewer is giving you a UI snapshot of the internal state of the application for every single event. And you can get this information for every single event. In just a second, I'll show you the snapshot of this UI hierarchy, which essentially tells you all the detailed information about the component that you have on the screen, all the properties of that component at any given moment in time. And it is extremely useful information to build a model of the application, right? Because you know that UI is the state, you got into the state by tapping on this location, on this component, and these are other components you can interact with, and these are other actions you can perform on these components, because they have registered callbacks, which you can get using static functions. So, what are the problems with Hierarchy Viewer? Hierarchy Viewer is great, it gives you a lot of information, but it is slow, and it actually requires doing of your devices. So in early stages of our research, we actually had to do some fairly risky stuff, which basically didn't guarantee that this device would be usable after doing that, but somehow all of our tablets are still working. But if you don't want to do that, there is another solution, better solution, faster solution, which is called UI Automator. Right now it's also part of SDK. And it essentially does exactly the same thing as Hierarchy Viewer. It gives you UI snapshots of the internal state of the application. However, it doesn't give you as complete information as Hierarchy Viewer. Okay? So when you actually build tools for testing applications, eventually you'll find out that either you rely on Hierarchy Viewer or UI Automator. This is going to be the bottleneck, because you'll have to decide how frequently you take snapshots of your application to do analysis. But the idea here is exactly the same. You get UI hierarchy that you can explore in this particular view. All right, any questions up to this point about any of the tools? We are moving into the really cool research part. In this part, I'll show you how we addressed some of these challenges in our tools. Yes?
You mentioned earlier that reproducing bugs that Monkey finds is difficult. Why don't we just track the events that Monkey produces and replay them?
Yes, you can, but in that case, you will also have to go through lots and lots of infeasible events.
True. Can we filter those somehow?
If you have a really robust solution for doing that, let me know.
Just spontaneous idea.
So basically, there is no way to filter them unless you do deeper analysis, unless you actually take snapshots of the application to understand whether this was a feasible or not feasible event. Just by running Monkey, you cannot get that information. So in other words, yes, you can retrace, but you're going to be going through 90% of false positives that will probably stop doing that after the first time, right?
For infeasible, you mean when it goes out of the lab?
Not necessarily, or some event that doesn't result in anything. So in other words, an event which doesn't move the application into different
So a lot of overhead with inputs that don't do anything, right?
Of course. Because Monkey doesn't have any knowledge of the application. All it can do is just throw in events, different types of events. And keep in mind that Monkey is not handling system level events, right? Only UI high level events. Good questions. Any other questions, guys? And again, when we refer to Monkey, I usually refer to Monkey as an automated tool. So Android Monkey, this is a particular implementation of this faster tester by Android, right? But of course we can implement it on our own, right? And of course, as you said, our own implementation may not be as robust, but we would be able to say this was a feasible event because it did not produce any noticeable changes in the state. So we just discard and we keep all of those there. Any other questions? All right, so in that case, I'm not sure whether we should start this right now or take a break. I can start right now, but then I'll have to come back and slightly revisit it.
Yeah, it's a bit early for the break because it's 10 minutes. So.
Okay, so in that case, let me start, and then once we come back from the break, I'll quickly review so that, and then in the break you will be able to ask any questions. Okay? So, why to improve these tools? You've seen different types of tools, right? Some of them have pros and cons, but obviously they're usable tools, right? Well, in our own research, we actually has done a survey with Android developers, which helped us quite a bit to understand their needs when it comes to testing Android applications. So of course, they said obvious things that we expected them to say. We need support for fragmentation. Collecting these scripts is expensive. We also need to maintain these scripts. They also said we like high-level languages. We want the tool to produce the scripts that we can understand. We don't want to deal with low-level events, right? We want API-level understanding of the test scripts. But what was even more surprising is that they said we don't care about code coverage. They said I want to test my application and I want my test scripts to capture usages, normal usages of this application by normal users. We would like to be able to test this application the way this application would be used in the field. The fact that you tell us that you have this level of statement coverage is not really interesting for us. Okay? This was very eye-opening to us to a certain degree because when you look pretty much to every single paper which does web-based testing, when you see here's another approach, they say we are better than some previous approach because we have high level of coverage. Okay? But when you actually look into what that tool does, in some cases, it's obviously not clear whether that test case actually represents actual usage of the application, right? And of course, there are many other issues that developers found with those tools, that some of them don't really work, some of them don't really work on devices, some of them work only on emulators. In fact, we got a lot of information. I'm just showing you a snapshot. So here you see word cloud with different tools that were used by developers. And in particular about random testing, what they said is that, yes, they said it's random testing, like Android Monkey is great for stress testing, it's great for finding corner cases, it's great to execute events and maybe potential sequences events that are hard for humans to come up with, so this is all great. But on the other hand, expressiveness. I mean, we cannot reproduce, we cannot understand, and we're not sure to which degree it is useful, especially in the case of complex applications. So our motivation was to come up with a solution that would help us to, first of all, be aware of history of execution of this application. So, in other words, we wanted to generate test scripts, which are not just throwing events at any given moment in time, not just to make sure that it was a feasible events, but we wanted to make sure that sequences of those events would make sense would make sense to users, okay? Would make sense to developers, would make sense to testers. We wanted these test cases to be natural, but we also wanted these test cases in some cases to be unnatural, maybe some sort of combination, right? We also wanted to learn these models from real data, and we wanted these test cases to be actionable. Of course, we wanted all this to run on real devices. We also wanted all this to run not only on devices, but on different devices. Also, we wanted to be able to do this on a larger scale, and we wanted this to be extensible to other tasks. So this is another set of papers that essentially tells you that manual testing is highly preferred over automated testing. And these are two surveys that were done by researchers from University of British Columbia, as well as Singapore and Microsoft research. Basically, both of these papers say that yes, there are lots of tools, but developers, when it comes to real testing of mobile applications, still are heavily relying on manual testing. Okay? And indeed, manual testing is great because it's a very rich source of information. When we execute application on the phone, we get a lot of data, right? We get information about inputs. We get information about new components that we interact with. We're getting information about which transitions we took from one state to another. We can get information about scenarios that we executed on this phone or on this application. However, what happens in practice, all this data is wasted, right? So we have a company, they have 3 developers, they tested this version of the application, none of the data is recorded or used for anything. We make changes to the application, we release the version, we retest it, and the process happens all over again, okay? We're not using this data for testing whatsoever. So one idea that what we have is, so we get a lot of data, right? From testing process. We can also get a lot of data if we ask just users to use that application. We can get a lot of data if users just use that application and are willing to share their users' data with us, right? And this data actually can be used for possibly generating test cases, right? And if we get a lot of data, maybe we can even generate better test cases, right? So essentially, this is the core of this idea: is if we can actually collect this data with low overhead, if we can collect this data without expensive instrumentation of the application, right? If we can collect this data on the real phone, and we can easily get this data, then we perhaps can rely on some models, maybe statistical models, to analyze this data and build these test cases in statistically rigorous way, and maybe even show that these test cases are going to represent what users actually do with applications. Of course, there is an important question: what do we do if we don't get enough data to build or to cover all possible transitions? In that case, we say we can also analyze underlying EPK, right? And we can extract some of these transitions, which we may not necessarily observe in real usage scenarios, but we can take this data into account while learning and building our model. So this is a high level and big idea. Okay? We can somehow instrument with variable overhead data collection. We can collect this data, we can analyze this data, we can build a model, and we can use that model to test our applications. So we came up with a solution that we call Monkey Lab. And one way how Monkey Lab differentiates from other solutions is that it collects and records the data from natural application users. Right? So users and testers just use application as in normal scenarios. And we are learning our models from real data. Our solution has contextual awareness of application execution history. Right? So when we generate scenarios, we know contextual awareness of application execution history. We want these scenarios to be actionable. So we want to be able to run them on real devices and emulators or emulators. And we want these scenarios to be human readable. So we want to present them in high level language. And of course we would like a full overhead for collecting this data. And we want to be able to run these scenarios on different devices. So we came up with a solution. We designed a solution which is relying on record, prime, generate, and validate framework, which is a fairly involved engineering exercise. So basically, this is one of those solutions where you need to spend a lot of time on building, a lot of time, before you can get your paper out. And indeed, we spend a lot of time. And I will go into this solution step by step, probably after the break, but just wanted to let you know that we've built lots of our tools, as well as we use some of the existing tools, which are part of the Android framework. And basically, I'll use it as an example to illustrate how you can also build your own testing tools. Hopefully, at the end, we'll be able to reason a little bit with you which opportunities exist. What else you can do with this research space. But I think this is where I'm going to stop. And then after the break, we're going to dive into the solution, and hopefully, I'll be able to convince you that this is great. Any questions? We have a few minutes for questions, or you can ask me questions during the break. I'm sure you'll get lots of questions once we start. Yes.
I was thinking about this crowdsourcing idea, and it's really interesting because there's one thing that only a human can tell you about your app, and does it look right? I mean, is the layout correct? Is there any text overflowing or something like that? You don't get that from an automated testing process. You need humans, and I think that's a really great idea.
Yes, and especially in terms of designing oracles, right? So yes, it is a great idea, but the major research problem is how do we automate part of the process, right? So absolutely, this is a great idea, but the solutions that exist out there are 100% made, and essentially they are relying on cheap labor, right? And there's some really cool technology that allow you to do that. That somebody from some country where we don't have even a device, they can actually do testing on some device via the browser. So yes, technologically speaking, there are many, many things we can do nowadays that we could not do before. But the major research challenge is how can we actually automate, if not everything, but how we can automate part of this process. And this solution is how we can automate part of this process, not everything. You're absolutely right that oracles is an extremely hard problem to automatically track. But some types of oracles